Good afternoon. I am Dr. Lina Calzada, and I am going to present the work entitled Activated Biochar Zinc Ferrite Composites for Efficient Bisphenol A Removal in Heterogeneous Photo-Fenton Process. Introduction. In recent years, considerable research has focused on various forms of biochar and metal oxide-loaded biochar due to their high stability, porous structure, and abundance of surface functional groups, such as carboxyl, hydroxyl, and aromatic moieties. Among these, biochar ferrite composites have shown strong potential for pollutant degradation via the heterogeneous Photo-Fenton process, offering advantages such as low cost, mill operation conditions, catalyst reusability, and complete degradation of contaminants. This study investigates the application of activated biochar zinc ferrite composites for the degradation of bisphenol A through the heterogeneous Photo-Fenton process. Biochar was derived from slow pyrolysis of agave waste, used as a biomass precursor at different temperatures, followed by chemical activation in acidic media to produce activated biochar. ABCF composites containing 10% of biochar were synthesized using a microwave-assisted precipitation method. Synthesis of materials. Activated biochar was obtained by a slow pyrolysis of agave waste at temperatures of 500 and 700 degrees C. Then, it was activated with phosphoric acid, followed by a second pyrolysis at 500 degrees C. The ABCF composites were synthesized by coprecipitation methods with an iron-zinc ratio of 2:1. First, iron was precipitated at pH 8 and then zinc at pH 10. Activated biochar was then added, followed by microwave treatment, obtaining the AB500CF and AB700CF composites. Pure zinc ferrites were also prepared without AB addition. Characterization of activated biochar. Thermogravimetric analysis of agave showed a considerable weight loss at 500 due to the removal of hemicellulose and cellulose, while at 700 degrees C, the weight loss was due to lignin. This led to the creation of a greater amount of mesopores in sample AB700. On the other hand, XRD analysis showed the presence of calcium species in the BC samples, which were largely eliminated after the activation treatment. Characterization of ABCF composites and zinc ferrites. Nitrogen physisorption analysis revealed very similar surface areas for both zinc ferrites, with the microwave treatment having a larger surface area. On the other hand, the composites had equal surface area, which were larger than the pure ferrites. XRD analysis of the ferrites and composites showed diffraction peaks corresponding to the cubic spinel structure, characteristic of zinc ferrites. The crystal size was similar among all samples, with size around 3 to 4 nanometers. FTIR analysis also confirmed the formation of ferrites, showing signals at 570 and 433 per centimeter, corresponding to the metal-oxygen bond in the tetrahedral and octahedral sites, respectively. In addition, a signal was observed in the composites around 900 per centimeter, due to the incorporation of activated biochar. On the other hand, semi-mashes show the incorporation of ferrite around the activated biochar. Heterogeneous Photo-Fenton reaction, degradation of BPA. In a typical BPA degradation, The contaminant solution was mixed with the corresponding sample, and the suspension was stirred in the dark for 30 minutes to reach adsorption-desorption equilibrium. Subsequently, hydrogen peroxide was added, and the UV LED lamp was immediately turned on. Finally, the obtained samples were analyzed using UV spectroscopy and high-performance liquid chromatography. Remember, the codes of the samples are BC biochar, AB activated biochar, and CF zinc ferrite. BPA adsorption experiments. In the results of BPA adsorption, BC700 showed higher adsorption than the BC500 sample due to the removal of lignin. AB samples showed a significant increase in BPA adsorption capacity. Moreover, the presence of AB in the composites improved their absorption capacity. In the experiments with different advanced oxidation processes with a CF aging sample, it was observed that the Photo-Fenton process showed greater BPA degradation compared to photocatalysis and the Fenton reaction. The degradation results with different volume of hydrogen peroxide with CF microwave sample showed that the addition of 322 microliters showed a higher reaction kinetic constant in the Photo-Fenton reaction. Finally, the ABCF composite exhibited a higher degradation rate than the CF microwave sample, achieving a total BPA removal within 40 minutes. Conclusions. Slow pyrolysis of agave waste at different temperatures produces biochar with diverse textural properties due to the removal of hemicellulose, cellulose, and lignin. This change showed a better performance in the BPA adsorption test. Activation with phosphoric acid reduced the high calcium content in the biochar samples, increasing the adsorption capacity in the activated biochar samples. The presence of biochar in ABCF composites improved the dispersion of ferrite, thereby enhancing the adsorption properties. The heterogeneous Photo-Fenton process showed the highest BPA degradation, followed by Fenton and photocatalysis. Furthermore, adjusting the volume of hydrogen peroxide is a key factor to optimize the generation of hydroxyl radicals in this reaction. Finally, the ABCF composites notably improve BPA degradation via the heterogeneous Photo-Fenton process. This research was funded by different SIP projects of the Instituto Politécnico Nacional. We also acknowledge CECITY Mexico for the granted fellowships. Thank you for visiting us.